Hello guys, welcome to my YouTube channel Religion Pharmacy. Today let's discuss about part 2 of our Pharmaceutical Chemistry 1 old syllabus D Pharmacy. And these are very important notes, questions with answers for your examination. Those who are writing old syllabus, there is Pharmaceutical Chemistry. Now on the date, the exam starts from the 3rd of their July, next month only. Our 12th question, already we have discussed up to 11 question in part 1. So if you were absent to that part 1 means, first go and observe that. The link is in the description. Note on sodium bicarbonate. Very simple here. Sodium bicarbonate is a white solid compound and it is found crystalline and powder form. It is also known as the baking soda because it is a main component of baking soda. It decomposes on heating. When you heat, it get decomposes. You know that baking soda, sodium bicarbonate, ENO powder. Do you know that ENO? ENO. That ENO, what you call no? That is only baking soda here. Formula is NaHCO3. Manufacture step: preparation of saturated ash solution, then carbonation of a saturated soda ash solution, then we are filtering of sodium bicarbonate, drying of wet sodium bicarbonate. Simple. This is the preparation technique in the laboratories. In the industries. Use of sodium bicarbonate is mainly used in the following industries like drugs and medical, leather or food products, baking soda, home applications, using to in a systemic antacid. It acts as a systemic antacid, sodium bicarbonate. Next, write a note on ORSL, that is oral rehydration salt solution. See, it is a type of the fluid replacement. It is a solution of glucose and electrolytes in a defined amount. When given orally, enhance the intestinal absorption of a salt and water. Thus, it can correct the electrolyte and water deficit. When we are giving orally, what it will do? It will enhance the intestinal absorption of salt water. The sodium, potassium, chlorine in ORS solution replaces loss of these electrolytes in stool. If anyone is suffering from the diarrhea or dysentery, then due to the excess of passing of stools, that is watery fluids, from that watery fluid, sodium, potassium, chlorine, water molecules get excreted. So to replace that all, we are using this ORSL. And citrate helps to control the acidosis. Clear? This one is the reduced osmolarity ORSL composition. It contains the sodium chloride, or also you can call it as a trisodium citrate based ORS. Glucose, it contains 13.5 gram, potassium chloride 1.5 gram, trisodium citrate 2.9 gram. Then note on handling and storage of radiopharmaceuticals. How can you handle? What procedures you have to keep it in your mind. See, here in 14 question, not only I am discussing only handling and storage, but also some of the applications also. Sometimes they will ask applications. If you don't know anything, means you write this from this. Whatever you know, you write. If they ask on the basis of the radiopharmaceuticals. Let's know the definition of this radioactive element. A radioactive element is an element with an unstable nucleus which radiates alpha, beta or gamma radiation and gets converted to the stable element. Basically, it is in unstable state. So, from unstable, it gets converted to the stable. Then both radioisotopes and Enriched stable isotopes are essential to a wide variety of applications in medicine, where they are used in the diagnosis and the treatment of the illness. In addition, extensive applications of isotopes in biomedical research finds wide parallel uses in research, chemistry, physics, biology. Simple. We are using this in the medicinal chemistry, in the drug chemistry, in the research and all. One part it has become. These radioactive elements, they have become one part of our life. Okay. Then applications in radioactive. See, simple application, they are used in medical diagnosis, and they are used to generate electricity, synthesis of the new element, preservation of food, help for the smoke detectors. They are most of the radioactive elements are present in the electric gadgets like your mobile phones, your laptops, MacBooks, and all. These contain the radioactive elements. Then isotopes commonly used in medicine. Chromium 51 used to label red blood cells and quantify gastrointestinal protein loss. Cobalt, okay, the performly means they are used for the external beam radiotherapy. Erbium used for relieving the arthritis pain in synovial joints. Iodine used in the cancer branch therapy in the prostate and brain. Also diagnostically to evaluate the filtration rate of kidneys and to diagnose deep vein thrombosis in the leg. It is widely used in the radioimmunology and also assay to show the presence of hormones in tiny quantities. These all are the applications of the radioisotopes. Handling of radioactive elements. How can you handle? See, the dispensing of radiopharmaceutical should be safe, reliable, and straightforward. Okay. Then recommended dose is based on the patient history, weight of the patient, body surface area, and other. If the body surface area of the patient is elder, means we are giving some high dose of the radioactive, like iodine we are giving high dose. If the body surface is less, the patient weight is less, then we are giving less quantity. Develops policies and procedure to ensure that correct drug with the correct dosage and dosage form are received by the correct patient at the correct time via route of administration. Role of pharmacist in the hospital with an isotope. So the hospital pharmacist should purchase or store, dispense the various isotopes required by the medical staff licensed to use these materials. Always these radioactive elements should be used on behalf of the medical license. In these institutions, the physician, upon deciding to prescribe radioactive material, will call the pharmacist and provide him with all the necessary information. The doctor should call him and tell him all the necessary information. The pharmacist will make necessary calculation in order to arrive for the required dosage and transfer the same amount of calculated dosage using a remote control pipette placed in the paper cap within a lead container and transported the patient for administration. See, the patient, he should always calculate the correct amount of the dose and he have to dispense. Storage condition. Storage means storing or keeping the radioactive waste in a proper safe place or facility with intention to retrieve it back at some time in the future. Because these radioactive elements, they are having a long shelf lives. Okay, so it takes years, many years, decades to convert to its half-life, means to just degrade to the half. The store should be located to minimize radiation risk. Like the location should be selected with due consideration, isolated area, low risk of flood and fire. It must be stable in order to ensure waste from the leakage or dispensing of radionuclides to the environment over a period of time and free from the earthquake threat. These all parameters they should follow. and they have to bury this, or they have to store these all radioactive elements. The store should be designated like to limit the radiation risk and radioactive dispersion with adequate shielding and ventilation, with adequate safety and security locks, so label and radiation warnings and all, a system of heat removal for high activity waste. These all signs, you are observing that signs and all on the radioactive element box. These all, that sign should be maintained. Disposal site assessment. See, geographical and hydrogeologically suitability, demography and future use of land, that land should be future use. Then accessibility, flora and fauna, mineral and deposit, metrology, options for radio waste disposal. These are the disposal site. Next is define error and types. Say errors. What are errors? Errors or experimental errors is a difference between a measurement and a true value, between two measured value. We have measured two values here. One is 12.5, another one is 12.7. The difference between the measured value and the true value. Your true value is 12.5, measured value is 12.7. Okay, now you have got that 0.2 as an error. This difference is called as error. Experimental error itself is measured by its accuracy and precision. Now, what is this accuracy? Accuracy measures how close a measured value is to the true value. How close? Now, 2.5, 2.7. How close the measured value? Now, measured value is 2.5. How close it from the... Are you getting what I am telling? 2.5, 2.7. This one is the true value. This one is the measured value. How close this measured true value? How close this measured value to the true value? It is closeness. Just 2 points. Okay, 0.2. Closeness is 0.2 closeness. That is the precision here. Since a true or accepted value for a physical quantity may be unknown, it is sometimes not possible to determine the accuracy of a measurement. Then precision, how closely two or more measurements agree with other. Example 7.2, 7.3, 7.4. What is the closeness? Only one closeness, 1.7.2, 7.3, 7.4. Are you getting? Only 1 point. That's two or more measurements agree with each other. Precision is sometimes referred to as a repeatability or reproducibility. We are repeating, no? 7.2, 7.3, 7.4, 7.5, 7.6, 7.7. Here we are considering two or more measurements. They are just closely resembled. Only 1 point is there, no? Just we are on that basis we are discussing the error. Next, last point, the measurement which is highly reproducible tends to give values which are very close to each other. Means the value which is very close, that value we are selecting and we are telling this error quantity. Two types of errors are there. One is a systemic error and random error. Now in this systemic error which is represent for the every measurement of the given quantity, it may be caused by a biogas of a part of the experiment, a miscalibrate, or the even faulty measuring instrument. These are all miscalibration, experimental problem, instrumental problem. These are the systemic error. Okay, and these systemic errors affect the accuracy of the experiment. Systemic errors cannot easily be analyzed by the statistical analysis. Okay, it cannot be easily analyzed. We cannot easily analyze this one, systemic error. Now random errors refers to the spread in the values of the physical quantity from one measurement of the quantity to the next. caused by the random fluctuation in the measurement value. Means randomly the values get differentiated, means the values get fluctuated, and these values can be known, easily known. But that which one, this value, this one, that is systemic, where instrument and some of the chemicals what we are using, no, their error may be present. So you cannot guess that. But here in random you can. Sometimes there also you cannot guess from where this error is coming, like this way. Sources of impurities: any material that affect the purity of the material of the interest is called impurity. Simple, any material which affect the purity gets called here impurities. They are undesired particles, impurities. Presence of impurities in the pharmaceutical substances may produce a toxic effects on the body and may also lower down the active strength of the pharmaceutical substances. If any small amount of impurity is present, means it will decreases the activity of the pharmaceutical product. Impurities commonly in chemical substances include small quantities of lead, arsenic, iron, chlorine and sulfate. What you are learning the limit test, no? Why? Because of this only. See, no product is 100% pure without any impurity. 1%, 0.5% impurities are there. But that impurities, if it is present in a limited amount, means then we can allow it. If it exceeds the limit value, then it degrades the product. Do you remember this? The sources of impurities: one is a raw material used, reagent used in the manufacturing process, then method or process used in the manufacture or method of manufacturing, chemical process, atmosphere contamination during the manufacturing process. These all are the source how the pharmaceuticals or they get impure. These all are the sources for impurities in pharmaceuticals. In intermediate products in the manufacturing process, defects in the manufacturing process, manufacturing hazards, inadequate strong conditions, decomposition of the product storage during storage, and accidental substitution or deliberate adulteration with the useless material. First one is raw material employed in the manufacture. See, impurities known to be associated with these chemicals may be carried through the manufacturing process and contaminate the final product. Raw means these are the initial materials to prepare anything. Raw materials are very important. If raw materials contain some of the impurities, means the product catch the impurity, the product lose its quality. Rock salt, calcium sulfate, magnesium chloride, the preparation of sodium chloride, rock salt. If any impurity here, in the raw material, quantity decreases. Reagents used in the manufacturing process. So, if reagent used in the manufacturing process are not completely removed by the washing, they may enter into the final products. Means these what contaminations are there, no, they may enter into the final product and they can decrease the quality of the drug. Method of the process used in the manufacturing. This is also one source for impurity. See, many drugs and chemicals are manufactured from different raw materials by using different methods. Some impurities are incorporated into the drugs during the manufacturing process. The type and amount of impurity present in the drug, they may vary. These all are, and a multiple step synthesis procedure is used where produces the intermediate compound. Major is in the manufacturing field, you may get some of the impurities like during manufacturing, during addition of the chemicals and all. And atmospheric contamination during the manufacturing process, it is also a major source of impurity. In the industrial area, the atmosphere is contaminated with the dust particles and gases like hydrogen sulfide, sulfur dioxide, black smoke. These also are prone to the contamination, impurities. During the manufacturing or purification of the pharmaceutical products, these impurities enter the final products and they decreases the purity of the product. Storage and uses of ferrous sulfate, calcium gluconate and iodine. Ferrous sulfate, it is used as an iron supplement used to treat the anemia. Storage, store in a well closed contained cool place. Yes, calcium gluconate store in a well container in a cool place. So used as a dietary supplement as calcium. Okay, if calcium is less in our body, then you are giving this calcium gluconate in the form of syrup. Calcium gluconate, what is this? It is a salt. Okay, calcium gluconate, a salt it is. And this calcium gluconate very helpful to regenerate the bones, to strengthen the bones. Used for the normal nerve and cardiac functions, calcium gluconate. Iodine, store in a well closed container and in a dark place, used to treat wounds, used to treat thyroid diseases, and used for the iron replacement. You know that iodine, this iodine, nothing but that iodine, used for wound. Yes, these are the very important questions and answers of part 1 and part 2. Both we have discussed here, part 1 as well as part 2. So watch this video until last. Take the notes if you want. Okay, every notes I am providing here only, best and better notes for you all, so that you can get very good marks and you can easily pass in our examination. Thank you.